let's talk about how we name it. The very first step is you need to find the longest chain of carbons, okay? 1, 2, 3, 4, 5. Now here's what's tricky. This is a three-dimensional molecule. We can name it any direction. So when we count for the longest chain, you count in all directions. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. A 5-carbon chain, 1 carbon methane, 2 carbon ethane, 3 carbon propane, 4 carbon butane, 5 carbon pentane. This is pentane. Now, what if, we should be writing, these are all hydrogens. I'm going to write the hydrogens the next couple times, and then you're never going to see it again. You have to remember there are hydrogens, okay? Because this is a pain to write, so I only do it a couple times. Now, so what I'm going to do is, I added a carbon group. This is a side group. This carbon is attached to my main chain. This is called a substituent. There is a 1-carbon chain attached to this carbon here, okay? A 1-carbon chain, 1 carbon is methane. If it's attached, this becomes methyl. Now, if I had a 2-carbon chain, it would be 2 carbons are ethane. This would be an ethyl group. Now, I have to make sure I didn't just mess up in my chain. So when you do your count, you're counting the longest chain. Let me show you all the ways you need to count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is still pentane. That's good. This is still pentane, but we added these substituents. Let's just keep this 1, 2, 3, 4, 5 pentane. But what do I do about this side group? Okay, let's number it, and I can number it from 1, 2, 3. Either let's just keep it like this for now. On the number 3 carbon is a 2-carbon chain. Remember, this is called a substituent. This side group. A 2-carbon is ethane. When it's attached, it's ethyl, okay? So this ethyl group, and there's only 1 ethyl, is on the 3-carbon. So this is 3-ethyl pentane. What that means is the name of my side group, ethane, because it's attached, is ethyl. Where is it located? It's on the number 3 in the chain. Now, the numbers are for the number of carbons in the chain. We're going to use these Greek prefixes for how many. Let me show you an example. I'm going to leave this here and just keep my numbers on. And I'm going to add okay? I have 1, 2, 3, 4, 5. This is still pentane. Let me count a couple ways to make sure it's still pentane, okay? 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. Still pentane. So I'm going to leave it 5. Now, I need to change my numbering, and let me show you why. I'm going to change my numbers here because this side group, we have a side group here, I need to renumber it because this side group is closer to this end. So and that's a small detail. If you had left it the same, we'd still be able to write the molecule. But that's, the numbering is, if you have something like a side group attached, you really should start renumber it from that end. Okay, so still pentane. What do I have attached? A 1-carbon chain. 1 carbon is methane when it's attached. Here's a methyl. This is also a methyl. Let me move my pentane. Okay. I have 2 methyls. 2, 3, 4, 5, etc. Okay? So I have dimethyl. Methyl group is a 1-carbon chain. When it's attached, it becomes methyl, not methane. I have 2 Where are they located? Actually, move this over here. They're on the number 2 and the number 3 carbon, okay? So the numbers are your location. The Greek prefixes are the quantity. I have two methyls, dimethyl. Those 2 methyls are located on the 2 and the 3 carbon, so it's called 2,3-dimethyl pentane.